Okay, question 10, we're doing question 10 here. Question 10 says the mass of a baby in the first 30 days of his life is given by m of t equal to t cubed minus 9t squared plus 3000, where t is in between 0 and 30. T is the time in days and m is the mass of the baby in grams. Now, in the previous video, we did solve question 10.1 and question 10.2. Now we're going to do question 10.3. The question says, on which day will this baby have a minimum mass? Okay. To do that, I'm going to move my board over here. So we're going to do a question 10.3 here. I think I need to post also the question over here. So we have 10.1. I'm right here 10.3. I mean 10.3. That says on which day will this baby have a minimum mass? Okay. To do that, we're going to differentiate the function. Why differentiate the function? Because it's why it gives us the stationary points, meaning it gives us the minimum and the maximum of a function. So here we're looking for the minimum mass. So we're going to do m of t derivative. Okay. And now we're going to set the derivative equal to 0, because at this point, when the derivative equal to 0, it's when we have the maximum or the minimum. Okay. Now we're going to do m of t is equal to t cubed minus 9t squared plus 3000. Okay. So m prime of t will be equal to 3t squared according to the derivative. Okay, remember, if we have like if we have like a x to the power of n, this is the derivative, this is like a times n times x to the power of n minus 1. So this will be like 3 times t squared minus 9 times 2 times t to the 2 minus 1. Okay, to the 2 minus 1. Plus 3000 derivative, the derivative of a constant is just 0. So this will be equal to 3t squared minus 18t. Okay, now we said we need to set the derivative of m equal to 0. Okay, so I'm going to sub 0 there. So we can see that each term in this function is a multiple of 3, so we can divide the terms by 3. I'll divide here by 3, divide by 3, or divide by 3. So this will be 0 equal to t squared minus 60. Now I can write it over here. So let me just, this means t squared minus 60 equal to 0. We can solve this by factorizing. I can take t as a common factor. So if I take t as a common factor, and then this will be t minus 6. This, because the law says the law of multiplication says a times b equal to 0, means that a equal to 0 or b equal to 0. Over here we're going to do the same thing. We're going to set, this means that t equal to 0 or t minus 6 is equal to 0. So for t equal to 0 it's already done. And then t minus 6 is equal to 0 means that t equal to 6. Now, remember, at 0 here is the time at birth, okay? And t equal to 6 means on the 6th day. So now, because the mass of the baby is decreasing to the initial mass by the 9, so now we say that the minimum will be on the 6th day. Okay, it's t equal to 6. So on the 6th day. 6th day on his birth. This is t equal to 0 is the initial day, so yeah, it's going to be like that, and then t is equal to 6. Thank you. Or sometimes someone else can also solve it differently, okay? Because we had like the minimum here by t equal to 0. Remember, at birth, the mass is 3000. We did it. Okay, it means 1 times 0, so it's just 3000, and then the mass will decrease, and it will come back to 3000 after 9 days. So we can consider okay, fine. This is how we can solve this. Okay, the time will be equal to 6 on the 6th day. Now let's also do question 10.3. 10.4 now. We did 10.3, now we do 10.4. 10.4 says, on which day will the baby's mass be decreasing the fastest? On which days? All right. Let's move. Now, 10.4. On which day will the mass of the baby be decreasing the fastest? Now, this means actually we need to find the point of inflection, okay, the second derivative. Okay, this is how we can calculate that. So we will say m of t derivative, okay, equal to 0. Okay, so it's actually the second derivative of m. So this will be okay. In the previous video, we already find the first derivative. It was equal to 3t squared minus 18t. Okay, so I can just use that. So we already have like m prime of t is equal to 3t squared minus 18t. The second derivative will be m prime prime of t will be equal to 6t minus 18t. Okay, so we say that this is the point of inflection is when mt is equal, the second derivative is equal to 0. So we substitute here by 0 equal to 6t minus 18t. Again, we can factorize here. We can take, I said 18t, no, not 18t, but 18, sorry. Yes. When you differentiate the t here will disappear. So we can take 6 as the common factor, or we don't need to do that. We can just divide the whole equation by 6. Divide the whole equation by 6, and then we have like 0 equal to t minus 3. So t, this means that if we move the 3 over, t will be 3. So we can say that the mass of the baby will decrease faster on the 3rd day. Okay, so t is equal to 3. Or another way is like what I was trying to say before, because where is it? Okay, if I look at the question here, it has its minimum. It has the minimum on day 6, right? And then and also the minimum was also on day 0. So they're like if we graph the function, it will be like the intercept of the parabola. Okay, I'm referring to the derivative of m. So now we can also find the line of the turning point of the parabola by working out the line of symmetry. So we can do 0 plus 6 over 2, which is equal to 3, the same 3 we got here. So this is just another way of solving that, because it has minimum at time equal to 0, another minimum at time equal to 6. So to find when it decreases faster, we can just do we can call it T1 and that's T2. So we can do T1 plus T2 over 2. So this will be 0 plus 6 over 2, and this is equal to 3. So the time will be equal to 3 after 3 days. So thank you.